So a lot of our derivatives are highly dependent on the tables that we use and applying the chain rule, and it's no different with the derivatives of inverse trig functions. So these are extremely important, especially when you get into the calculus 2 and calculus 3. You'll see these quite a bit. So let's just run through how to use the tables to do this, and make sure you kind of have an understanding before you dig into Newton here. So there are some basic rules, right? And that's kind of what we have in these first couple of slides here. We're just applying the basic. This is in your chart or in your derivatives table. So the derivative of the inverse sine function is 1 over the square root of 1 minus x squared. So if we were to think about the chain rule, right? So the derivative with respect to the derivative with respect to x of the inverse sine of u. Okay, so you've seen how the chain rule works. That's going to equal 1 over the square root of 1 minus u squared du. So again, the idea is that we're going to identify what u is here, and then once we plug that in, we'll multiply by the derivative of that term. Here you can see the derivative of the inverse cosine function. Now, just briefly, I do want to give you a reminder of what we mean when we say the inverse trig functions. Okay, so if I said to you, we have some angle theta, okay, and that angle theta it creates a point right here. It goes through this point, square root of 3 over 2 comma 1/2. Okay. And I said to you, okay, so what is this angle, right? What is this angle theta that goes through this point, square root of 3 over 2 comma 1/2? If I wanted to know what is the angle value, theta, right? That's theta. What is the theta value? The question I would be asking you is this: what is the inverse sine of 1/2? Okay, so the inverse sine of 1/2. So the reason I chose this is because the y value right here is 1/2, and I know that sine has a y value. Sine is the y value from the unit circle. So the angle that goes through this point is the result of taking the inverse sine. Okay, so my answers here are going to be angle values, and obviously the value of this angle right here would be pi over 6. So the point is, we take the sine of angle values and the inverse sine of x or y or u or whatever value results in an angle value. Okay, so theta is here, and it gives us some ratio, and then in the inverse trig functions, our result is an angle value. Okay, so with that in mind, right, when we go in and perhaps we have to evaluate these derivatives at a certain point, that's going to play a role in kind of how this all works. Okay, so I've asked you to find the inverse sine of 5, or find the derivative of 5 times the inverse sine of 3x. So we're going to identify that u is equal to 3x. Now look, I'm working this out a little differently than what you see here in the PowerPoint. du is going to be 3 dx. So if I use that rule, right? So the rule that I would refer to would be the inverse sine of u is equal to 1 over the square root of 1 minus u squared du. So I'm going to go replace all those things with like du. I replace that with 3 dx, and then I've got to multiply 1 over the square root of 1 minus u squared. So in our case, again, u is equal to 3x, so we're going to have 3x squared down here, and there's a 5 out front, so we don't want to forget to keep up with that 5. So when I multiply this out, right, 5 times 3 is 15 over the square root of 1 minus. So when I square 3x, I'm going to multiply it by itself. That's 9x squared. Okay, so the derivative here, f prime of x, is 15 over the square root of 1 minus 9x squared. Right here, I've got the inverse cosine of x over 7. I want to find its derivative. So again, we're going to identify that u is equal to x over 7, and this makes du equal to 1/7 dx. Now you'll notice there's a bit of an error right here in the PowerPoint, or at least on this page. We proceed and they resolve that error on the next page. So maybe it's not an error, maybe it's just this is a different way of writing what I've done over here. Okay. So again, we're going to say that the inverse cosine, right? The inverse cosine is going to equal -1 over. Let me rewrite that. Got a little happy with the radical there. So the inverse sign is going to equal -1. The derivative is -1 over the square root of 1 minus u squared du. So again, I've identified du to be 1/7 dx, and here u is x over 7. So you can see on the next page that the publisher's PowerPoint sort of does the same thing. We got -1 over the square root of 1 minus x over 7 squared times du, right? So du is 1/7 dx. Excuse me. So simplifying our fraction, right, this is -1 over, this 7 is just going to go right in front of the radical. And to square a fraction, recall that we have to square the top and the bottom, right? Now there's some additional steps right here because this just doesn't look pretty. We're going to get a common denominator, right? So we're going to come over here, see if we can get the red pen right there, and we're going to have 1 replaced by 49 over 49, right? So that's how we were able to generate -1 over 7 times the square root of 49 minus x squared. Okay. So I think they may have left the 7 out in front of here. I'm not sure why they did that, but well, excuse me, I do know why. I made the mistake this time. So I've got the square root of this fraction, right? Square root of this fraction. This is 7 over 1. So when I take the square root of a fraction, remember that I have 7 times the square root of the top, which is just going to be this term here, over the square root of the bottom. So the square root of the bottom is 7, right? And those 7s cancel. So that's why we list our final answer as -1 over the square root of 49 minus x squared. So a lot of times you can see the steps worked out in the PowerPoint, but it's little details like this that I really want to focus on in the PowerPoint. I'm hoping that watching these videos is kind of giving you an idea of why we're doing what we're doing. Okay, so how did that 7 go away, right? And that's the reason why, because of how we combine those two things under the radical. So here we introduce some inverse tangent and cotangent functions. Again, we're applying the chain rule. There's nothing really out of the ordinary in this problem, so I'm just going to leave that with you there. The same thing here with the inverse cotangent. Again, we're applying that rule. We're applying the chain rule here, and again, if you had a hard time figuring out what u is, it's the thing that we're taking the inverse cotangent of, right? So u is x squared and du is 2x dx. So just a couple of things to note there. Here's our functions for secant and cosecant, and we go through a few of the operations here. Now notice we have an absolute value with cosecant, right? So you want to keep up with that as you're working through the problems. We can talk about, sort of what happens here with the absolute value and simplifying. So we figure out u is equal to 3x to the third, and that makes du 9x squared. And so this is the 9x squared, right? That's our du term that we're plugging in. So if I go in and look, right, so the integral, or excuse me, the derivative, getting ahead of myself, the derivative of secant to the -1 u would be equal to 1 over the absolute value of u times u squared minus 1 times du. So notice that this du is going to be in the numerator. We could rewrite it like this. We could write du like so. So du over the absolute value. Now, I can take out an x squared right here, right? So I could take out the 3 is positive. I could take out the x squared. And the reason I can take that out of the absolute value is because when you square a negative number, you're still going to result with a positive value. So this simplifies down to 3x squared times the absolute value of x. And that's how we're able to go in and get rid of the x squareds. 3 will go into 9 3 times. So that result right here makes a little more sense. Here's an interesting one with 8x. So you'll notice, right? Excuse me for that. You'll notice that we've got u equal to 8x, and du is equal to 8dx. Okay. So if u is equal to 8x and du is equal to 8dx, the derivative of the inverse cosecant is negative 1 over u, the absolute value of u, times the square root of u squared minus 1. Plugging in 8x for u and 8 for dx is how we wind up with this result, negative 8 and 8x like so. So the 8's cancel. We still have that negative out front. And this is our final result here. So please, 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 I always ask for this. I would love your feedback. Give me some information. Give me some things that I can do to make the experience better for you. Hopefully you've got an idea of what you're going to be doing as you go into Newton and looking at that homework there. Again, if you have any questions, okay, I embrace your questions. I want to add to the video library here. So please do what you need to let me know. What is it that you need in order to do these assignments better, to understand better. I look forward to hearing from you, and good luck with this assignment.